Are you there? Unmute yourselves, leave yourselves unmuted for the whole time so we can have a good chat.
Yep, I'm here.
And Swetha, are you there too?
Yeah.
Oh, there you are. Good. It's showing me the speaker view, so I don't get to see you all in one go. Oh, wow, great. Okay, well, everybody, thank you for joining us in the Engineering in Space panel. Hopefully this is going to be interesting for you. We've got people here, from satellites going off to the moon, to satellites doing manufacturing in low Earth orbit, and thermal vacuum chambers that are big enough to swallow up entire spacecraft. I think we've got a really good broad mix of people on this panel. So firstly, I guess I'll ask you to just quickly introduce yourself. So let's start as you're on my screen with Swetha.
Hi, everyone. My name is Shweta Kotichintala, and I'm an aerospace engineer. Right now, I work with ExoMars, and I'm doing business development, interestingly. Yeah.
Thank you, Swetha. Now let's go to Paula.
Hi, I'm Paula Maddox. I'm lead electronics engineer for a company called SpaceForge, and doing electronics.
Fantastic. Thank you, Paula. And last but not least, Chris.
Hi, my name's Chris Jenkins-Watkins. I work for Rail Space. I'm a junior test operator, which means I basically work on thermal vacuum chambers, which tests basically spacecraft, satellites, space hardware, that sort of thing.
Fantastic. Thank you. It's been really exciting for me to meet you all in advance of this and talk to you a bit about what you're doing in space. And it's going to be really exciting to share that with our audience. And perhaps I'll start with Paula. Coming to you, I know there's been some really interesting news recently from SpaceForge, and I've looked into it. It's fascinating to think that you can build a spacecraft, launch it from the UK, and build some, use it to manufacture some materials in space, and then bring it back down again. It's absolutely fascinating, and I'm really excited for you to tell us a little bit more about it.
Yeah, thank you. We're a new company to the UK, and we are launching. I've got our first launch, as you say, from the UK this year. And we are launching a manufacturing platform where you'll be able to manufacture things where you have microgravity, where there's no atmosphere, which helps a number of chemical processes. And then we'll also be able to retrieve the satellite. We have what we call a soft capture sort of landing system. So if you make anything that's fragile, fingers crossed, and all being well, and if our systems all go well, when it lands, it will still be intact. It won't shatter from the impact.
That's fantastic. So for you then, what are the key challenges then for building a spacecraft to do this?
There are many challenges, but for me, the electronics, I think there are two key ones. The first one is the temperature ranges. We used to, in certain parts of the world, fairly warm and fairly cold weather. In space, we can go up to 200 Celsius, and we can go down to minus 200 Celsius. So this represents a huge problem in terms of managing heat where it is. You can't just blow a fan over it to cool it down because there's no air. So that's one of the biggest challenges. And the other one is the effects of radiation, or cosmic rays, as some of the people like to call them, where you get what are called single event upsets. These typically can flip bits inside your processor. There was an election in Belgium where one of the candidates suddenly won by 4,096 votes. Because a ray had made it down through and just caught the computer at just the right time. There are other examples of aircrafts nearly crashing and all sorts of fun things because of this phenomenon. Once you get outside of the Earth's atmosphere, so you're in low Earth orbit in space, these effects become a lot stronger and a lot more frequent because the atmosphere protects us.
So just picking up on something you said there, so flipping a bit. So that's as simple as your processor has a 0 in it and the cosmic ray comes in and flips it to a 1?
Yep, it's as simple as that.
Wow.
And it could be when you're, there was a Super Mario game on the NES. It was a great example where the guy's playing a level and a bit flipped, and all of a sudden he jumped up really high in the game to a place you could never get to.
Wow.
So if you imagine you can have that problem, if you get a blue screen of death, that kind of problem. The big challenge with space, of course, is you can't switch it off and back on again because there's no way to get there and flick the switch.
Yeah. So without revealing your trade secrets, then what are you doing to counteract these single event upsets and this cosmic radiation interfering with your spacecraft?
So there are a number of technologies you can use. Ironically, some of the technologies that were used in the 60s for launches to space used what's called ferroelectric magnetic memory, which is a little coil with a bit of wire wrapped around it. And those are immune to these events. So we are using some of the memory that's similar to that. We're also, where we have key systems, we're putting redundancy in. So if one crashes, the other one can still go. And by careful selection of the parts, we are buying some radiation hardened microprocessors for key parts.
Fantastic. It's fascinating. You've got to consider all that stuff before you even get to your satellite doing its mission of manufacturing whatever it is you're going to manufacture in space and then capture on the ground in your soft landing. You've got to do all those things. They've all got to work in order to receive your material back from space that you've manufactured. And
yeah,
it's great. and of course, the news I saw this week was that Space Forge is going to be the first payload on the Virgin Orbit flight from Cornwall this year. So it's going to be a launch of a UK built satellite from a launch site in the UK. So it's a real big first for us. Really exciting for us going forward in the space industry.
Yeah, it's really exciting, and it's great to be a part of it.
Yes, I'm sure we'll all be tuned to the live feeds and all those things that come down from Virgin Orbit on that mission. It'd be brilliant to see that going forwards. And you mentioned obviously the environment in space and testing things. And this is where I'm going to bring Chris in, because Chris, you said at RAL Space, and I know for a fact you've got some pretty big thermal vacuum chambers up there, and you're, I guess, taking these equipments, and before they get sent to space, you're putting them in an environment to simulate space to see how they operate and how they work. So can you tell us a little bit more about what you're doing up there?
Yeah. So as one of the difficulties Paula's mentioned earlier is temperature is a big difficulty, because like when you go to space, you can have temperature ranges from 200 degrees, minus 200 degrees. And so I have here a model. A small model of what we use here is a thermal vacuum chamber. So we have, at the moment, we have 2 5-meter diameter thermal vacuum chambers. To put that into perspective, a double-decker bus is about 4.4 meters high, so a bit bigger than a double-decker bus. So we can fit in, large space equipment, space hardware, satellites and whatnot. So yeah, this whole testing is to test temperature. It's also to test pressure as well. As you go into space, as you know, it's low pressures. So we're testing to, I think, 10 to the minus 7 millibar, which is pretty much, closest to vacuum of space you can get. So that's an important step that we have to consider to make sure we can reach those extreme environments of space. Another thing we have to take into factor is contamination as well. So that's a huge thing in space. You don't want to contaminate anything. So you got to make sure everything that goes into space is squeaky clean as well. And also you're dealing with pressures. You've got to make sure nothing's like going to burst, for instance. And also that nothing's going to melt on the spacecraft, really. That's a big issue you could face with.
So you're simulating the harsh environment of space right here on Earth inside a big metal can. And that model you showed us there on your desk is a small model of your big chamber, your 5-meter chambers. And
yeah, exactly.
Of course, not all vacuum chambers are huge. Some of them are small. I think I've seen some that are smaller than the one you had in your hand. So this is all the different equipment that's required to test a spacecraft before it goes off into space. And I guess like Paula said, you can't switch it off and on. You can't go and send an engineer up to fix it. So you have to make sure it works right first time. And I expect a lot of the money that goes into building a satellite goes into just all that testing that you have to do on the ground before you even get it anywhere near a launch vehicle. So talking about launch vehicles and sending things off into space, Swetha, you and I, we've spoken recently about your mission in your company and your startup. It's very exciting, a new startup. And we're talking about CubeSats, small satellites going out beyond Earth orbit, going out to the moon and onto Mars, and a market that's out there for these small satellites to go off into space and do really useful stuff. It's really exciting. I wonder if you could tell us a little about ExoBotics and what you're doing.
Right. Thank you very much for that kind of introduction. So we're developing CubeSats, and for the ones who may not be aware of what a CubeSat is, it is a very small version of a giant satellite, if I can put it in these terms. And just like Chris, I have a little model here, but it's actually true to its size. So this is a 3D printed model of that's blurring. There we go. This is a CubeSat, and it's called, true to its name, it looks like a cube, so it's called a CubeSat. So it's 10 centimeters by 10 centimeters by 10 centimeters, and it's less than a kilogram. So the reason why I'm mentioning these is because space is expensive. It's expensive to put things, to actually send mass out of, Earth's atmosphere. So it's expensive. So in order to reduce the cost and make space more economical and accessible, CubeSats have appeared in the market just about 15 years ago, I think, into the market. And ever since then, it's been a fantastic development of this small satellite market and small satellite subsystems. And every single issue that Paul and Chris talked about, the CubeSats have to go through all of them, like all the electronic components and the PCBs, all the radiation hardening and all these issues that Paul was talking about. We have to work them. And then again, we have to test them in the TVAC that Chris is talking about, obviously, which simulates the whole space environment. So now CubeSats have been in low Earth orbit up until now, which is about 600 to 700 kilometers from Earth. But now our startup is actually enabling like that value beyond Earth's orbit. So we have a mission to go to the moon, which is upcoming soon. So the CubeSats will actually be sent into lunar orbit soon. And there'll be more about it in news as the time gets closer. So yes, we're sending CubeSats to the lunar orbit. And the next step would hopefully be Mars.
So, everybody can go to Exobotic Space and have a look and see your vision and your mission, what you're planning to do. But can you give us a little bit of background into what missions you think these CubeSats can do at the moon? Is it just like moon observation with a camera, or is there other things these things can do?
Yes, so it's almost like tech demonstration because it's never been done before, never been done commercially for sure. So it's to see actually if these work. So they're called tech demo missions. So CubeSat usually are used for like comms and remote sensing, and you can have a small camera on them. You can take a picture of them. You can live stream things from there. So they're like multiple things you can do, which would give you that beautiful overview effect to actually see what's going on. Like when you see it from sort of like ISS level, kind of a view, that you have these beautiful streams on YouTube that are live constantly. You can keep them in your desktop background where the camera is constantly running 24 hours. So yes, there's many things you can do with CubeSats, and the biggest advantage is they are not that expensive. Just to put a perspective, right now it costs about £1,000 to put a gram into space. So sort of like up and down, CubeSats cost about like $30,000 US, which is 1 U, which is like one of these, which is like about a kilogram of those. So they're usually like 3 U's, 6 U's, 12 U's. So it's like, the number goes up. But the idea is that, they have become more accessible to people, especially to students and to educational institutions, wherein they're able to perform their own science. So you can send your own payload on them, your own sensors, like whatever you want to develop. Potentially, these are also modular, and hence they can also be converted into rovers. And hopefully you can put like a seismometer sensor on it or something to check some seismic activity on the moon and so on and so forth. So, but it's endless. Possibilities are endless with CubeSats.
So the modular nature of these CubeSats, then. So yeah. I did a look on your website, and I saw there was a little model of a CubeSat. It's a couple of you, but you could just see inside some wheels. So that really blew my mind. That your model is to build CubeSats in that form factor, but actually be able to tuck other things inside them and potentially put a vehicle down on the moon using your CubeSat technology.
So we will be going with a vehicle to the moon. So, for example, best way to describe this is like you're buying a bus ticket, right? So a bus takes you from this point A to point B. So there are lunar landers like that. There are commercial lunar landers across the world. There's like about 3 of them from the US, and there's like a lot more being developed in Japan and like, different parts of the world. So this decade of 2020s is actually very big for lunar economy, in the sense that you will hear a lot more about these moon missions, upcoming commercial missions. So we get to go on those lunar landers, and then we get to go onto the moon. So they provide us a way to get to the moon.
Wow, it's so fascinating, and it's so inspiring to think that all this is happening right here in the UK, and that there's some fantastic engineers and scientists working out there and enjoying their jobs and springing out of bed in the morning. And I look forward to the day that we have a live stream from a CubeSat from the moon. Perhaps in my mind, it's not a live stream of the surface of the moon, but perhaps looking back towards the Earth. How fascinating would that be to see the Earth from 240,000 miles away, and give us all a bit of context around where we live and the fragility of this little ball in space that we all live on. But I'm fascinated with all things in engineering and all things space, but I'm also fascinated about the journeys that people have taken to get to where they are. So I'd like to spend a little bit of the time we've got together as a group with an audience around us, to spend some time just highlighting your journeys and your journey to where you've got today. So I'm an ex-apprentice. I'm from Airbus Defence and Space, and I'm a raging space nerd. So I'm really lucky. I work in the space industry in the UK, and I'm doubly fortunate I get to talk to people about what I do and bring space into the mainstream. But Paula, over to you. Can you give us just a minute or two on your journey, your engineering journey, your scientific journey, and what you've done, and perhaps some highlights for you along the way?
Yeah, thank you. My journey to what I'm doing now has been quite unconventional. I've always had a passion for electronics. I started fixing my relatives' televisions when I was 10 back in the 80s. My mother and father were very supportive, so they got me a little electronics kit, and I was making light bulbs flash and little things that went beep and stuff. And this was great for me. I went to college, did a course in marine telecommunications and electronics, which was really interesting. And then I got sidelined and I got stuck in computers for about 25 years doing computer engineering and network engineering, which was great from a sort of, it gave me a big sort of system view of the things and how things work together, rather than just the finer detail that you get with the electronics view sometimes. Then I set up my own business, doing electronics, making synthesizers and things behind me. And I wanted a new challenge. And, I applied for a job at Space Forge. I didn't know anything about electronics and space. And here I am today. I've learned an awful lot in the last 8-9 months. And it's really good. It's really challenging. It's very interesting. There's always something new to learn every day, which is what I love about it. There are no 2 days are the same, and there's always something fun to learn about.
Oh, fantastic. So from synthesizers to space, hey?
Yeah.
And there's a lot of questions in the chat actually about what is all that equipment behind you, Paula. So there's a lot of interest out there.
So these are various types of synthesizers. There's modular synthesizers, there, and keyboard ones and things there. So
oh, fantastic.
they make lots of fancy beeps.
Well, that actually eventually turns into music, right?
Eventually, yeah. In the hands of better skilled people than myself, it does turn into music, yes.
Fantastic, thank you. And Chris, now I happen to know that you're a recently graduated ex-apprentice, so perhaps you could tell us a little bit about your journey. Perhaps not as diverse as Paula's, and you've come from school and gone to college and then done an apprenticeship. But perhaps you could tell us a little about your journey and what gets you out of bed in the morning.
Yeah, well, I finished school. I went to college firstly I went to college to learn plumbing, and then found out it wasn't for me. I went then to do electrical installation because I like using my hands a lot, but I then quickly found that electrical in general is interesting. I like to dig a bit deeper thinking wise. So then from there I looked at apprenticeships. It was more of because I didn't know if I wanted to go to uni or not. So I thought apprenticeship might be a good stepping stone in the future, because I know you can go from being an apprentice and progress in your education at the same time. A lot of people think apprenticeships are only like a hands-on skill, where you can actually learn, like for instance, engineering, you do learn education on the side. So I thought, get an apprenticeship, and at the same time, I'm getting paid for the apprenticeship, so I'm getting paid for my time, and you're learning hands-on, and you get education, and then that's how I ended up here, really. I just progressed from my apprenticeship. It was about 4 years with SDFC, so that's at the Harwell campus in Oxfordshire. So that's going through different departments of their site. So they've got particle accelerators. They have this one department called Central Laser Facilities. So you're looking at laser beams. Just all sorts of, like, tons of science, technology, and engineering. And then I came to this one placement, Ralph Space, and that's where I found this is where I want to be. This is somewhere that's I'd never thought, to be honest, working in the space industry. It's always something you saw on TV. Never actually thought it was attainable, really. And then it just went from there.
Fantastic. And it's I guess it's you tried plumbing and it wasn't for you, but I wonder if that plumbing job you did for a while it turned you into a better engineer without you even knowing it. Perhaps you were getting skills that you didn't know you needed. So being an engineer working in space isn't all about being an engineer. You need to be able to communicate, you need to be able to write, you need to be able to get up and go to work. And I guess you got some of those skills along the way when you were learning your plumbing. But it's fantastic to hear your journey, that you tried lots of different things and then you found the one thing that you really enjoyed doing. And that's a really good piece of advice, I guess, to try new things and take opportunities as they come. then you might find something that you really enjoy, and if you can make that your job, even better. So thanks for that, Chris. It's been interesting. I look forward to watching how you go future from here as well.
Yes.
So Swetha, what about you then? So I know we've spoken a little bit about your journey, and you've got a really good journey to draw upon, and a really broader range of skills in the background. And I guess for me, it's been quite exciting to say that you're part of a new space startup, but it's been quite a journey for you to get to where you are.
Definitely. I'm originally from India, so my education has been in India, where I did my uni over there for aerospace engineering. I mean, education is different, right, in different countries. So I didn't even know what apprenticeship was like, for example. We don't even have that system back there. But what happened is I have about 13 years of industry experience right now in cross industries, from oil and gas to aviation to aerospace. When I was in uni, I formed a team with like some really smart people across India. Like we formed like a consortium of different universities, and we built India's first ever CubeSat. And it was a student satellite, and it was launched in 2010. So that gave me an exposure into structures. And so basically my aerospace background is through mechanical engineering base. So that gave me an exposure into structures and component placement and all the other aspects of building a CubeSat. And from then my career took a slightly different turn, where I went into oil and gas energy sector, and then aviation, and now coming back into commercial space as well. So what this did is it gave me a full overview of what it takes to actually make a product and sell it, or not necessarily just sell it, but how do you finish a product? How do you make it consumer worthy, for example, and even in mission worthy, for example. So basically it's design, testing, analysis, project management, procurement, safety, reliability, quality, export control. So I got to dip my fingers into like all these things a little bit to understand that engineering is, you're not just sitting and taking a spanner and fixing things. Like engineering means there's so many different aspects to it before you can call a product which is worthy of being sold or being used for people. So what it did is it developed a kind of logical and critical thinking, funnily enough, to the point that it's sharpened the problem solving skills to the point that I'm actually venturing into entrepreneurship now, from an engineering to an entrepreneurial space, which is very interesting for the kind of problems. The theme is the same, like you're trying to solve problems basically. So yeah, it's been an interesting journey. So it took me to a few places. So I've lived in 5 different countries, and now I'm here in the UK.
Fantastic. I mean, it's really interesting what you say there about all the different things that go into being an engineer, all the different roles in engineering. And perhaps I can bring in one of the questions that's on the Q&A there, is that someone's asking for advice from a young engineering graduate that wants to break into the space industry, but without a relevant academic specialization. So now it's an interesting question, because they've mentioned they're a young engineering graduate, and now without a relevant academic specialization. I think I'm going to ignore that bit, because actually a young engineering graduate wanting to break into space industry. Have you got any advice, Swetha, for someone who wants to break into space? So what maybe some guidance and some quick wins, some short steps that people can take?
Actually, maybe we can consider the without academic specialization part as well. So for a young graduate to break into the space industry would probably be Chris or someone like that, to be able to tell more about like the apprenticeship pathways or like internships and like graduate trainees. Like, for example, large companies like, say, European Space Agency, or like, Rolls-Royce and Derby, or like, any of these companies, they have graduate programs, graduate schemes, wherein you qualify from, you pass out, you graduate from your university, and then they hire you and they train you. They call you rotation engineers. They put you in all engineering teams.
Yeah.
Now, for the ones with not academical specialization per se, I'm assuming they're talking about non-traditional space careers, for example. There's been a big push about it. So there's a common misconception that to be a part of space industry, you have to be an aerospace engineer, or you have to be some form of an engineer. I know this is engineering in space panel, but I just want to highlight that it doesn't have to be just engineering to be a part of space industry. I mean, it's like any other industry. We need people from finance, we need project managers, we need business developers, we need sales, we need PR, like we need so many different elements, graphic designers, like you name it. And it's beyond engineering. So it's definitely an industry that requires all kinds of skill set into it, for sure.
Yeah, it's an interesting question, because that leads me to think that perhaps there's a view out there that if you're studying engineering, but it's not space engineering or aerospace engineering, that eliminates you from being a space engineer. And my personal view, and perhaps what you've said, is that that's not true, that we need so many different engineers doing so many different disciplines. There's a lot you can do with an engineering degree. Depends what it is. But there are other things like there is the UK SEDS, there's the students' societies around space, and they're a really great network for bringing you into that next step and giving you visibility and understanding of what's out there for you. So I hope the anonymous attendee who left us that question at least goes some way to answering your question. Actually, there's a response saying, very inspiring journey, Swetha. Congratulations on being a young, successful entrepreneur. There you go. So there you go. I've got some pretty big curveball questions coming in here, and I like these curveball questions. They're not curveball questions that are going to fall into a trap, but perhaps, Paula, I'm going to ask you one of the questions on here, and you're dreading now, which is coming to you, aren't you? But I'm going to ask you, do you want to go to space yourself?
It's a difficult question to answer. At the moment, no. I'm not keen on travel at the best of times, but at the same time, if somebody was to say, hey, here's a free pass on the next SpaceX thing to the ISS, I'd jump at it.
You would.
But it's not something I would actively go for. But yeah, if the chance came, yeah, sure, why not?
Yeah. Very similar to me. I the same way. If they wanted a middle-aged, overweight, and underfit analog for an astronaut to send to space to see how badly they perform compared to a real astronaut, then I would be the one. But it's interesting that you don't aspire to be an astronaut. That's the thing. You don't have to aspire to be an astronaut to go and work in space. There's so many engineers and scientists working on every single mission that puts an astronaut into space or a vehicle into space that actually there's lots more out there for people to do, not being an astronaut.
There are thousands of people behind every launch, and I like making things.
Okay, so there's another question's come in, and I'm going to put this to you, Chris, because you're the one out of all of us that's closest to school, having been at school. There's a question from Sarah Dedgostar saying, what's recommended subjects to be chosen in school that best suit your line of career? Now, it's fairly obvious when you're talking about STEM and science, technology, engineering, and maths, but I wonder if there's anything people don't consider beyond the maths and English and science that would be helpful in your line of career.
I did like maths, English, science. I also did engineering. I also liked computer science. I think that just puts in perspective how many different avenues there are just in like space industry in general. Like, yeah, you can do computer science, you can get into the tech behind everything. Yeah.
Yeah, it's a tricky one, isn't it? I get asked this question quite a lot about what's the things I should study to be an engineer, and I guess it's obvious really on the surface what are the really key things that you need. But again, you don't have to be an A-star student in these things either. I know for myself, yeah. I wasn't an A-star student in maths and English and science, and I barely scraped through maths and English and science at school, and I had to go back to college and restudy for maths and English. So it's by no means an A-star route, and it's really interesting to think about how young people are thinking about their futures and what things they should be studying, because it's clearly we're maybe hopefully turning some young people onto science and engineering careers out there, and they want our advice. So I'll have a quick look through the questions again. Oh wow, look at that. Now there's a school have come on and asked a question, and they're designing their own space robots. Okay, what would you recommend for things? What materials would you recommend for things that go into space? Now, I think materials is a very tricky one, and I wonder whether we could just pick up on some materials. And Swetha, I wonder if you've got any thoughts on materials for spacecraft. Have you got anything there? Are you thinking about the materials? Well, you held up a 3D printed CubeSat. Would you be sending a 3D printed plastic CubeSat into space?
I think they're also actually talking about actually sending 3D printers themselves into space, so that they can start making these in orbit and things like that. But usually, you want to make them lighter because you're trying to reduce the weight so that it reduces the launch cost for you. So usually they are like aluminum alloys.
Yeah.
So I think something on the lines of those. So
aluminium. So if you're in school and you want to use aluminium in your spacecraft that you're building, go get a roll of tin foil, because actually it's not made from tin. It's actually made from aluminium. It's very thin aluminium. Actually, right here I've got a piece of spacecraft thermal blanket. Now this is a piece of thermal blanket that was made for a satellite. Didn't end up on the satellite, clearly, because I've got it. But you'll see inside there lots of little layers. They're all aluminium inside there. So lots of thin layers of aluminium. So if you can build your satellite and put some aluminium around it, you'll make it look just like something that goes off into space, and you'll be using the same material that spacecraft are made from. There's a question in there. Let's have a look. Oh, this is a non-engineering question. Okay, let's have this. Let's have one-word answers from all of you because we're going to have to wrap up shortly. Which is your favorite planet? Now I'm going to start with this one, right? I'm going to start with this one. I'm going to give you my favorite planet. My favorite planet, and I know what everybody who knows me is going to say, it's Mars, because I love Mars. And you can see from behind me, I've got some rovers. But actually, my favorite planet is Earth, okay, because it's where I live. It's where all my family are. My favorite planet is Earth. So what is your favorite planet, Paula?
I'm going to be probably slightly predictable and say Saturn, just because it looks really pretty.
Saturn, because it looks pretty. Yeah. And I guess to see Saturn with your own eye through a telescope is a pretty phenomenal thing. I remember the first time I saw Jupiter and its moons through a satellite, and then seeing Saturn and the rings. Yeah, for sure.
Yeah.
Excellent. And Swetha, what about you? What's your favorite planet? And I guess it doesn't have to be in our solar system.
Well, I have a funny answer for this. I have preference. First is Neptune and the second is Earth, simply because when I was about in year 3, there was a solar system skit, and that's the planet they gave me. So I had like a little blurb about the planet, the distance from the sun, and like, so I think I started off with Neptune and somehow I landed Earth later. So maybe I should say Neptune.
Neptune, there you go. I wonder how often Neptune comes up in a list of people's favorite planets.
Doesn't get enough press, no.
And Chris, you've been sitting there trembling, thinking he's going to come to me next and ask me what my favorite planet is. So.
Pluto gets more press than Neptune for sure. So.
I'd say probably Earth again.
Yeah.
It's yeah, I mean, most relatable, most everything's going on Earth, so it's the coolest planet going.
Yeah, it is absolutely. Well, and maybe not cool in terms of temperature, but definitely cool.
Yeah, I'd go there.
I'm glad none of you chose to be controversial and go for Pluto.
I was thinking it.
Or some random exoplanet around another star. we've got a bit more time left, so I'm going to keep going through the questions that we've got in there. And there's a specific question about CubeSats and space debris, and I wonder, Swetha, thinking of your mission and your CubeSats, do you consider the through life, the end-to-end life of these satellites as part of your business model?
Early stages, it's just a demonstration of the tech. So it depends on the mission planning, what the mission comprises of, what it needs to do, and what the customer wanted to do it. So for that, yes, obviously we'll plan the mission timeline for that. So after that, for now, yes, CubeSats are definitely. For example, I think about over 2,000 CubeSats have been launched ever since they've come into existence. So that said, there are also like constellations upcoming, because there's like benefits of it. Obviously, like for example, if you take Starlink or so on and so forth, they provide internet to Earth, and like the other forms is like we want to have GPS, for example. You want GPS on Moon or on Mars, and like to be able to see these pictures. So yes, for now, I think what was the question again? Would they turn into debris or?
Well, yeah, it's just consideration of space debris. I guess there's a big element these days of sustainability and things going forward. So the more we talk about exciting launching stuff into space, obviously, the more we've got to think about the through life impact of that in space.
Sure. Actually, yes. So there are companies, obviously, who are doing the space cleanup projects. And like, one of the companies that's actually in Harvard called Astroscale, like they're doing brilliant about it. And they're coming up with this new methodologies, like having these giant magnets on them or something like that to trap the satellite once its life period is done, and then, to take it away. So they are partnering with like constellation satellite companies, wherein there's a large number of, these CubeSats that are sent into the orbit. So they have a way of trying to remove them.
And perhaps a similar sort of question towards you, Paula, in Space Forge. So I guess your mission there is to launch something, manufacture something, and then bring it back. So there's a consideration of not leaving stuff behind in orbit there. Is it? And I guess there's an element of orbit manufacturing in orbit is less impact on the environment on Earth as it is already, isn't it? Straight away out of the box.
Yeah, I mean, there's a lot of advantages. There are a number of disadvantages, like ease of access to the material. I think one of the key things that we're doing differently to a lot of other people is when we get the satellite back to Earth, we plan to refurbish it and then send it again. So we're not constantly wasting material. We plan to reuse as much as possible for each launch, which helps keep carbon emissions down. Also helps with reuse and cost. So
That's fantastic. So at some point in the future, then I'll be able to come and visit you in Space Forge, and you'll be able to show me something that's been to space and returned again, and been on that full. Well, I want to say the full orbit, but it's not the full orbit. It's the full mission evolution from. Yeah.
Very much so. You're welcome to.
Well, that'd be fantastic. It's really exciting to see that the direction of travel for engineering and science in the UK, and these startup companies that are here, all trying to plug holes in the market. And you don't consider things like GPS on Mars as being a requirement, do you? But absolutely, if you're going to have vehicles on Mars navigating on the surface in the future, and potentially humans, you're going to have to navigate, and the ones that are there navigating using the stars, that might seem like old tech in the future when you've got a constellation of CubeSats up there. You could have a constellation of CubeSats manufacturing other satellites in the orbit of Mars. You converge all of these things, and also providing a GPS signal for vehicles on the surface. It's fantastic. But let's not forget, all those things that get up to space have to go and be tested. They have to go through, Chris, these huge thermal vacuum chambers up at RAIL-Space. So fantastic. So we've hit 1:15, which is sort of the end of our time. And I wondered if any of the panelists have anything else they wanted to say, anything else, any messages they wanted to give, or any advice they wanted to give to anybody, and sort of open floor to you, really.
So if I can, the only thing I would say is I don't have a degree. I have a HNC in electronics. What I think counts massively when you're going for jobs and looking for things is your enthusiasm and your drive and your passion for the subject. If you have a passion for a subject, you'll find a way of doing it and making it your living.
Fantastic. Thank you, Paula. That's really, really good advice. And actually, I put my hand up there and say I don't have a degree. I have a HNC as well, and I'm actually enrolling on a degree apprenticeship this year, age 40 something. So I've been trying to do it for years, and COVID got in the way. So I'm hoping that by the time I'm 50, which is a scary thing to say, that I'm going to have a degree under my belt. But actually, it's not helped me back at all up to this point. So thank you for bringing that in. And Chris and Swetha, have you got anything else you'd like to say to our audience while you've got the floor?
I'd say don't be pressurized that you should go to university. It's still apprenticeships. They've evolved from past times. You can still get a degree through an apprenticeship, like for instance I am at the moment. I'm starting a degree in September, so it wasn't a thought I'd have leaving school that I'd be going to university, but here I am, going towards a degree. It's like another pathway, essentially.
Thank you, Chris. And Swetha.
Yeah, my opinion would be I'm a strong advocate of engineering because I strongly believe it develops logical thinking and critical thinking and analytical thinking. I mean, this is the advice I give my sister as well, who's pursuing her engineering now. If anyone's on the edge to understand whether it's for them or not, it's not necessarily about building things and fixing things. It's actually trying to develop a way of thinking. So engineering helps you develop that kind of problem solving skill set. So do go for it. But then at the same time, I want to echo what they said, like you need passion to do this. Like, for example, I don't have a business degree as of now, but I'm still venturing into different elements of it. And I believe this kind of motivation comes from the problem solving capability of training from engineering, I suppose. So basically, if you have passion, I think, yeah, definitely that's the only way, I think. And funnily enough, most people in space industry, passion is the most common word I hear. Then compared to the other industries, I've been into other industries, but I think passion is what drives the space industry. Definitely.
Wow, what a brilliant note to end on. Thank you so much. And thank you all for joining me. And I know some of you have joined in this panel at late notice. So I really appreciate you working with me and helping me to bring this panel. And I hope the audience have got something out of it. So